Hello everybody, welcome back. Today we're going to be starting the last section for Chapter 7, Properties of Systems of Linear Equations. So we're going to look at determine the number of solutions from a linear set. Okay? So there's three scenarios. The first is when we have parallel lines. This means there's not going to be any solutions. So the lines have the same slope and they are going on forever. So same slope, different y-intercept, the lines will run and they'll always be the same distance apart, so therefore they don't intersect, so there's no solution. Next is the intersection of the lines. This is the common question that we have. This happens the majority of the time. This is when the slopes are different, obviously. So if the slopes are different, that means they're going to intersect at one point. Okay? And the next is coincident lines. So this is an infinite number of solutions. So this is when you have like two equations. So for example, you have these in these two equations, and they're both in general form, right? And if you rearrange these, what you end up with, so for example, you rearrange these for y, what would happen is they would actually be the identical equations. They don't look the same right now. I mean, you may be looking at properties and saying, oh yeah, this is 3 times more, whatever the case may be. But we're going to show you how to do that. And so this is an infinite number of solutions. You don't see a red line here. That's because it's underneath, right? So these are overlapping lines. So there's an infinite number of solutions because the equations can be rearranged to equal the same thing, right? Okay? So let's look at the first example. Example 1, it says determine the number of solutions of a linear system. So we have two equations here. There's a couple ways you can do it. Obviously, you can change them in the y equal form, or you can do it differently and work these out. There is a typo. I do apologize, so I'm going to have to fix that. You do need to put a negative in front of the 2. My apologies. There should have been a negative here, so we will fix that on our sheet. All right, just a little typo, no big deal. All right, so let's take a look at the first example here. All right, and then we'll do these B and C afterwards. So again, like you can rearrange this. So if I rearrange this in a slope-intercept form, as you guys know how to do, so if we rewrite this, we would subtract the x from both sides, and we'd have subtracting x from both sides, and there we have. Okay, so you subtract the x from both sides. The second equation is a little harder to rearrange, but we can do it. So we take our equation. We're going to add the 2x to both sides. So we take this 2x and we're going to add it. I'm going to put it in front, obviously, just to have it that y because I'm x plus b form. Then we're going to divide everything through by a negative 2. So in doing so, if we divide everything through by negative 2, we're going to end up with, that's gone, obviously, leaves us with y. 2 divided by negative 2 would obviously just be negative 1x, or negative x. And 4 divided by negative 2 would give us the negative 2. All right. So we do indeed end up with the same equation once rearranged into slope-intercept form. So to determine the number of solutions, this would mean that we would have, go back here a little bit. So since the equations are the same, there are an infinite number of solutions. So these literally land in the same spot. Another thing you can do with this, you can use the Desmos program. So I'm going to bring that up for you. Desmos. Alright, so if you use the Desmos program, it's desmos.com. We can put the two original equations in. So we had the original was x plus y equal to negative 2. And then the second equation was negative 2x minus 2y equal to 4. And you'll see, notice it turns different color, right? Because I haven't put the equation in and boom, there you are, right? So it's red, and I put the equation in and it turns blue because they overlap, alright? And then the next one, what you could also do is you could you could multiply coefficients, right? So you could leave this first equation alone, I'm just showing you another method. So you just leave this alone, all right? And then the second one, to make the coefficient the same in the x, so what we could do is we could take this equation, and you could multiply this whole thing by -2, right? So if I put brackets around here, and I multiply this whole thing by -2, all right? Multiply this whole thing, like I said, by -2, we would end up with 4x plus 2y equal to 2. Equal to more negative 1 out to 2, right? Well, obviously, if they both have the same x coefficient, everything else would have to be the same. So what we see here is they're different, right? But that doesn't help with the parallel. That's the only issue, right? So you would still have to work it through. I mean, I can see that it's going to be, this is going to be 2/3, and this is going to be 1/2 for the -2/3, and this one here will be a little different, right? But slope intercept form is probably the best way to go. So we'll do that. All right. Like I said, probably not the best method here, but I just want to show you that you could try that, just to show that at least it's not infinite number of solutions, but it is important to find that slope. So what we'll do is we'll take this equation and we'll rearrange it for y. Okay. Rearrange that for y, and we get, this is what we did in chapter 6, right, the rearranging, so that's why it was very important, okay, that we know how to rearrange our formulas, right? And then we divide by 6. So it would be -4 divided by 6. Oh. And obviously a 10 divided by 6 as well. Okay, and then obviously this, the arrow. Divide, then we want to simplify, so that -4/3 becomes, -4/6 becomes 2/3. And -5, or -10/6 becomes -5/3, right? Do the same thing with the second equation. Do the same thing with the second equation. And 2y is going to come over the other side. Or sorry, the 2x is going to come over the side. It's negative on the left-hand side, so we're going to add it to the right-hand side. And then we divide through by -1. When we divide through by -1, it's obviously gone, that's why we did it, and the -2x becomes, the +2 becomes -2, and then the -1 divided by -1 becomes +2. So obviously you can see that the slopes are different. So this would show that we have, since the equations are, so since, make this red, my apologies. So since the slopes are different, the lines will intersect at exactly one point, and the linear system has one solution, right? So it's going to intersect at one point. Okay? And then the last scenario we have here, we'll do the same. rearranging the formulas. Take the 3x to the opposite side, right? Minus 3x minus 1 plus 3x on the left-hand side, so we get rid of it, and it's already set to y, so that's done. So we have the equation, slope-intercept form, y equals negative 3x minus 1. The same thing with the second equation. Okay. Rearrange for y. So we're going to add the 6x to both sides because it's negative on this side, so we're going to get rid of that. Right? Add the 6x. Oh, too much, sorry. And divide through by negative 2. And we divide through by negative 2. We get negative 3x. And that would give us negative 2. That would give us negative 6. Minus 6. So in this one, you'll notice that the slopes are equal, but the y-intercepts are different. So this means that we have parallel lines. Okay. So because since the slopes are the same and the y-intercepts are different, the lines are parallel. And a linear system has no solutions. Okay? So, 3 scenarios. The first scenario is when the equations are the exact same, so they have the same slope and the same y-intercept. So that means there's an infinite number of solutions because they overlap. Then the second scenario is the different slopes, right? So if we have different slopes, that means that it's exactly 1 point. It doesn't matter if the x and y, or it doesn't matter if the y-intercepts are the same or not. Okay, it's not going to make a difference. Right? If it's the same, that just means that's the intersection point, right? Obviously. So that's the scenario 1 solution. Okay, and then one solution. And then when you rearrange your equations, they have the same slope, but the y-intercepts are different. Okay. This is a scenario that you're going to have no solutions because they're parallel. The lines are always running parallel. Okay? That's it for this video. So there's a check your understanding question you can work on there, and there are the solutions for the check your understanding. 1 infinite no. Okay? So in the next video we'll start with example 2 for section 7.6. Hope everybody enjoyed the videos, and we'll talk again soon.